Hello and welcome to Unit 7 Integrals. We are done with the units of derivatives. We will never be getting rid of derivatives, but we are at least done with the units of derivatives, and we are moving on to integrals, which of course deals with derivatives since we are in calculus, but we're going to be looking at integrals instead. So let's get started. Given f prime of x equals x squared plus 3, what was the original function? So I'm thinking to myself, what do I need to have as the original function? What was up here to bring back down so that I can get x squared? Well, I know I subtract 1, so I know if this was x cubed here, I could bring the x cubed down, make it 3, make it x squared, but I don't have a 3 out in front, so I must have to divide by 3 too. And if I have just a 3, I know I must have been with 3x. So what was the original function? But x cubed over 3 plus 3x. That's what f of x must have been. And why do I have that divided by 3? Because if I bring that 3 down, I need there to be a coefficient of 1, and 3 divided by 3 is 1. Now, the one thing that we don't know is if there was a constant out here. I could have had any number that I wanted to. And so we don't know if there was a number here or not. And that's going to be called a constant. And that's something very important that you guys are going to have to remember, to always add a c to the end of it, of any indefinite integral. So these are called indefinite integrals. We're going to do definite integrals later on. These are called indefinite integrals. So the rule that we have is that if we have any x to the n power, the integral of x to the n, we know that the integral of that will be x to the n plus 1 divided by n plus 1 plus c. And that's exactly what we did here. We added to 1 from the x squared, and then we divided by the n plus 1, which is 3 here, and we added that c. Now, what does this dx stand for? That dx stands for, or it shows us that we're taking the integral with respect to x. And so that's why it's really important to have there. We're taking the integral with respect to x. Just as if we were taking a derivative and we put d over dx to know that we're taking the derivative with respect to x, this is showing us that the integral is with respect to x. So the example here, the integral of x squared, we're going to add 1 x cubed over 3 plus c. With this one, we have the integral of 3x to the 4th with respect to, take the integral of 3x to the 4th with respect to x. The one thing that you know is that this is a constant. We can bring the 3 out in front to write it as 3 multiplied by the integral of x to the 4th dx, which is then 3 multiplied by x to the 5th, add 1 over 5 plus c. And you can just finish that off by saying 3/5 x to the 5th plus c. What I'd like you to do right now is to pause the video and attempt these last 4 here. You will have to distribute in this one, and you will have to rewrite the square root. So try that. Pause the video. Okay, let's look at these. Hopefully you got these as your answers. Few things to look at and remember is that when you have when you divide by a fraction, you multiply by the reciprocal. So in the first one you have 10 over 3, since the 5 times 2 is 10. Let's look here, the square root, x to the 3 halves. And then the only other thing to look at is the integral of -4 is -4x. So take a look and let me know if you have questions in class. Moving on to the next 4 here. Nothing too different for these top 2. Again, how you could think of this is the integral with the 2/3 out in front of x to the 5 halves minus 6 times the integral of x to the 4/3 plus 2 times the integral of x to the -1/2 minus the integral of 7. And you would have dx's after all of these. Now, do I expect you to write it like that? Absolutely not. Do I expect that you just do this on your own? Sure, but know that the integral of summation is the summation of the integrals. So just as a reminder, you can do that and write out all the integrals, but I do not expect you to do that. So we're going to get 2/3 x raised to the 7/2 as we added 1 divided by 7/2 minus 6x raised to the 7/3 over 7/3 plus 2 here. Now negative 1/2 plus 1 is x to the 1/2 divided by 1/2 minus 7x plus c. Ooh. And now the even more fun part, 2/3 multiplied by 2/7 is 4/21 x to the 7/2 minus 6 times 3/7 is 18/7 x to the 7/3 plus 2 times 2 is 4 x to the 1/2 minus 7x plus c. Now again, would I like to see it as 4/21 square root of x to the 7th minus 18/7 cubed root of x to the 7th plus 4 square root of x minus 7x plus c? You could. I'm not going to make you do that, but you need to see that those are equivalent. Okay, looking at this next one here. For the basic integration, since we're only on day 1, what we're going to do is bring the 4 out in front, and yes, we will have to distribute x plus 6 times x plus 6. We have not done u substitution yet, so we'll do this. So this will give us x squared plus 12x plus 36. So we can get 4 multiplied by the integral of this. The integral of that is x cubed over 3 plus 12x squared over 2 plus 36x and plus c. And we can leave it mostly like this if we wanted to. There's not a common denominator to take out. And so I would leave it as that. Could you distribute the 4 if you wanted to? Sure, but why bother making a mistake there? Now we'll get into 2 that are important here. The integral of 1 over x. If we made this x to the negative 1 dx and took the integral of that, you would get x to the 0 over 0 and we'd be in big trouble, of course. And so we can't do that. What you have to recognize is what is the derivative, what function gives you, when taking the derivative, gives you 1 over x. And you guys should all be thinking ln of x. Now, when you take the integral of the 1 over x, you actually have to have the absolute value symbols around the x. So the integral of 1 over x is the natural log of the absolute value of x, and then add the plus c at the end. So something you have to memorize. Shouldn't be too big of a surprise for you though. Integral of 4 e to the x, again I would take the 4 out, take the integral of e to the x. Well, we know the integral of e to the x is just e to the x because the derivative of e to the x is just e to the x. So we're just going to get 4 e to the x plus c. Done. And for the final one on this page, if we look at it, we notice that everything is divided by x squared. So personally, I would just write it out as the integral of 3x to the 5th. Why? Well, I'm going to divide every single term in the numerator by x squared because it's in the denominator. Minus 4x to the 4th plus 7x to the 1st plus 6x to the negative 2nd dx. And so now it's just completing it. So 3x to the 6 over 6 minus 4x to the 5th over 5 plus 7x squared over 2 plus 6x to the negative 1, notice that, divided by negative 1 plus c. And so all I would do here, because I don't like the negative exponents, is rewrite it and simplify any fractions that you can. So 1/2 x to the 6 minus 6 over x plus c, and be done. So now let's get into something a little bit different. Let's get into trig functions. Not a good way to memorize these except as the opposite. So if you see a c, if a trig function starts with a c, it is not negative because it's opposite of what we would think. So the integral of cosine x is just sine x, but now if it's not c, the integral of sine x is negative cosine x. A couple important ones to remember. The integral of secant squared x is tan x. We sometimes forget that. And another one that we forget is secant x tan x is secant x. So again, know these. You should know those right away. And then another two that would be good for the AP test or in just calculus in general is knowing those other two. So if we look at this one, the integral, again, that 7 can come out in front, so we get 7. And then the integral of cosine is just sine x. And then plus c. Done. 1 over cosine squared theta, you sit there and go, not on there. But we can rewrite this as the integral of secant squared theta. And we know what secant squared theta is. We just wrote that, or just started. So we know secant squared theta is tan theta plus c. And again, why am I using theta? Because the original problem has theta in it. In the table, we have x. So that's why we're using theta, though, down here. Moving on, sine theta divided by cosine squared theta. So let's see here. I know cosine squared theta is secant theta, so let's rewrite that as sine theta. Secant squared theta, d theta. And I then go back and look at my chart, and I'm sitting there going, I don't see sine theta secant theta. It's not up there, so maybe that's not how I need to do it. So let's see here. How can I rewrite this? Well, I can rewrite this as sine theta divided by cosine theta multiplied by 1 over cosine theta. So I still get my cosine squared theta in there, and I still have sine, and I need parentheses and put d theta here. What does this equal? Well, this is tangent, and this is secant theta. It's right there. Secant x tan x is secant x. So I know this is secant theta plus c. So it's just reworking this and figuring out how to get it to look like something that we know the integral of. In the last page here, the initial value of an integral. So this is what we were talking about at the very beginning. What happens when you need to know the initial condition? When I find the integral, I don't know what the original function was because of this plus c. So if I take the integral of x squared plus 6, I'm going to get x cubed over 3 plus 6x plus c. And that is what our original function is. We can call it y. Well, if I know the point x comma y, then I can find our plus c. So if I plug in 4 for x and 3 for y, so 3 equals 4 cubed over 3 plus 6 times 4 plus c. And so our goal is to solve for c. So let's see, this is 64 over 3 plus 24 plus c. We get negative 21 minus 64 over 3 to equal c. Let's see here, this is going to multiply by 3 to give us negative 63. So negative 63 and negative 64 is negative 127 over 3 to equal c. And so what is our original function? We go back to here. We go y equals x cubed over 3 plus 6x minus 127 over 3. And that is the original function based on this initial condition. So that's it. So looking at the last problem here, the integral of sine x is negative cosine x. So please do not forget to have the negative portion of it plus c. And that's our original function, so we'll say y equals. Remember that when we plug in 0, this is xy, plug in 0 on the unit circle, this is x value at 0. It's 1 comma 0, and so it's the 1. So we're going to get 1 equals negative 1 plus c, because that's what, if I'm going to show it all out here, negative cosine of 0 plus c, negative cosine of 0, cosine of 0 is 1. So we get c to equal 2. And so we're going to have the final original function to be y equals negative cosine of x plus 2. Your math joke for the day is, what did the triangle say to the circle? triangle. Say to the circle, you are pointless. Funny one. Anyways, hope you have a good day, and I will see you in class.